The BETAG eGuidance platform has engaging eModules available. Here is how to access damage analysis. Go to betaglc.com and create a new account. Once created, log in and you'll see the available courses on the training pyramid. Pick Medium Panel Level 1. Choose Enroll Me to access the course content. From the course matrix at the top, choose Damage Analysis in the eModules section. Now, let's look at some of the material from the Damage Analysis eModule. Thanks for watching. Hello, my name is Dings. Welcome to this module on damage analysis. I will be here to guide you through this eModule. By the end of this course, you will be able to identify the different types of damage, identify the different shapes of damage, mark up damage, explain the extent of the damage. This diagram represents the different levels of damage and their proportion of the volume of repairs. The top part of the diagram represents non-structural and drivable damage, which is about 60% of the repair volume and is the largest proportion of repairs. The blue section shows structural and non-drivable damage. The yellow section represents heavy damage, and, often, total loss. In this module, we will focus on damage analysis relating to the top section of this image, which is non-structural and drivable damage. Let's look at elastic deformation. If you apply light force to sheet metal or a panel, it deforms slightly. If you then release it, and it returns to its original shape, this is elastic deformation. If you apply more force to a panel and it deforms, then, once released, it does not return to its original shape, this is called plastic deformation. In most sharp damage, the center of the impact area has been plastically deformed. The type of deformation that occurs depends on the energy applied. Low energy causes elastic deformation. Deeper deformation occurs as the energy increases. Once the yield point of the material is reached, then plastic deformation occurs. The greater the energy, the larger the area of plastic deformation. On the outside of the damage, there is also elastic deformation. The greater the energy, the sharper the plastic deformation. If more energy is applied, the tensile limit of the material is reached, which will then cause the material to rip, or crack. This limit will depend on the specific material. Let's look at how damage happens, and the different types of damage areas. Here is the plastic deformation. And here is the elastic deformation. Let's look at the different zones of the damage. The dotted line shows the original body shape. This is the shape the panel was before it was damaged. The red area shows the direct impact area. This is the area which received the direct damage, or the contact zone, and, most of the time, the center of the damage. More often than not, the material is stretched and plastically deformed. If the damage occurs at a body line, then this will also be deformed. The yellow area is the energy transmission area, known as the elastic or energy zone. This is caused by the kinetic energy of the impact. Usually, this area is elastically deformed, and easily repaired. The green area is called the crown, and this is the zone where the metal has deformed outward, and stiffened up. This can be both plastically, and elastically, deformed. Now let's move on to marking the damage. Here, we will learn how to mark up the different areas of the damage. There are several reasons for marking up damage. To be able to explain the damage better to the customer. To make it clearer in pictures and to see the full extent of the damage. To improve the communication between the estimator and the technician with regards to the extent of the damage. To be able to calculate the repair cost. To help create a repair plan. Let's look at how this is done. The area being marked now is the body line and the plastic deformation. The next area to be marked is the elastic deformation. The crown, which is the zone where the metal was pushed out, we mark by drawing eyebrows. In this picture, the whole damage is marked, and shows the full extent of the damage to the panel. The damage size is the same, but it looks larger, because the marking makes it more visual. Let's explain this in more detail. When marking up the damage, there are 3 different markings used. These make it easier for everyone to understand. The first area that we mark is the impact point, or plastic deformation, of the damage. If there is a body line, this is usually where the impact is. This is marked by covering the full extent of the area. Also, mark the body line as a guide for the repair process. The next thing to mark is the energy zone, or elastic deformation. The energy zone is everything that is lower than the original surface area. This is marked with an outline indicating the size of the low area. Then, we mark the crowns. The crowns are all the areas that are higher than the original shape of the panel. These need attention during the repair, to help relieve stress in the panel, and to get it back to its original shape. The crown is marked with eyebrows. Crowns can be elastically deformed. These are known as lazy crowns. And tight crowns are plastically deformed. The sharper the crown, the more tightly curved the markings. Finally, the damage can be circled to show the total size. This is the repair area, and is also the area the customer pays to have repaired.